In this video, I'll illustrate for you how to solve the problems like what we had in the second law of motion worksheet. So these are the problems that involve the second law of motion, which is that the net force, which I'll symbolize as capital F with the subscript net, equals the object's mass times its acceleration. In order to solve these problems, we're going to have to work with an equation, but we may not need to work with that exact form. So you'll remember that I gave you a couple different other forms of the equation so that we could work with, and they are all equivalent to the original. One of them is that the force divided by the mass equals acceleration, and the last one was that the force divided by the acceleration equals the mass. So all these equations, like I said, are equivalent to each other. We get from one to the other just by doing properties that are allowed by algebra, so either multiplying or dividing both sides by the same thing. And so we can convert between these forms if we want to. I've given you these equations straight up just because I know that some of you have not had as much algebra, and so this will make it easier for us to work with this without having to do all the algebra behind it. In order to get started on this problem, we're going to have to look at what the question is asking for, and then decide which form of the equation is going to be best for us based on that. We can see that the question statement here is, what is the acceleration? We're interested in the acceleration of the falling bowling ball. Because we are interested in acceleration, we should look for the equation that is solved for acceleration. In other words, we want to see an equation where we have acceleration equal to some other expression involving other stuff. And in this case, that's going to be our center equation. This one is helpful for us because once we plug in the net force and mass, we have a direct route to getting the acceleration. Whatever number we end up with is going to be equal to the acceleration, which is good for us in this question. Now that we know that, we can start to plug in the information that we have to solve for acceleration. So if the net force divided by mass is equal to acceleration, we'll take our net force, and they've given that as an unbalanced force of negative 12 pounds. Remember that Newton is our unit of force that we're typically going to see. And also it's told that this is the unbalanced force here, another way of saying the net force. And so this should be a good thing for us. We also want to look for the mass, and that's earlier in the problem where it says it's a mass of 7.51 kilograms. So I plugged in the negative 12.2 newtons for the net force because that's what it represents. I plugged in the 7.51 for the mass because that's what it represents. And we should have something that is ready and solved for the acceleration we're looking for. One thing that I'd like you to remind you of is the fact that the unit Newton is equivalent to kilograms times meters per second squared. And so just to go through how the units work out for this. We can take a look here and see that the kilogram part on top and the kilogram part on bottom will cancel each other out. This will leave us with something in meters per second squared, the only remaining unit there, which is good for us. That is actually a unit of acceleration, so this is consistent with what we should be looking for. When we actually go through and solve, we should find that this will lead us to the fact that the numbers come out to negative 1.62, units come out to meters per second squared, and that will be equal to our acceleration. And so that will solve this original question for the thing that we were asked for. So key strategies in this problem. First off, we started with our equation, our second law of motion equation. We had three different forms of that. We decided on the one that was solved for acceleration because that's what we're looking for here. So solved for acceleration, meaning that acceleration is on its own on one side of the equation. So we plugged in our numbers and checked that the units do in fact cancel to give us something that we want. We ended up with the acceleration, in this case, negative 1.62. I'll go through a couple other examples of other problems in future videos, but this one is going to be fairly representative of types of problems you should be seeing in this unit.